In this lesson, we're going to look at incomplete quadratics and also simplifying square roots, which is a skill that we're going to need to solve some of these quadratics. So this says quadratics in the form ax squared plus c equals 0 are known as incomplete quadratics. These types of equations can sometimes be solved using the zero product law and the difference of perfect squares factoring. So we're first going to look at two incomplete quadratics that can be solved with a zero product law. So this first one, we have x squared equals 16. If I set this equal to 0, I get x squared minus 16 equals 0. Then factoring, this does factor using the difference of perfect squares. And then if I solve from each of those factors, I am going to get that x either equals -4 or +4. Looking at the next one, I'm also going to set this equal to 0, so I subtract 12. And I get 5x squared minus 20 equals 0. So I'm going to factor out a 5. And then I see I can further factor with difference of perfect squares. And solving this one, the 5 equals 0 is nothing, so I get answers of -2 and +2. So those two quadratics, because they lacked a bx term, it says because they lack a bx term, so that x term, they have an x squared term and then a constant, incomplete quadratics can also be solved by isolating the x squared term and taking the square root of both sides of the equation. So we're going to use that other method and check our answers with part 1 just to make sure that we get the same answers. So actually this process doesn't involve setting it equal to 0 because we don't have to use factoring. So basically I'm trying to isolate the x squared just like I would isolate the x in a linear equation. So this one's already done for me, right? So basically I just take the square root of both sides. Now the square root of 16 is 4. But if I just write that 4 is my answer, we know from the factoring method for solving that we need two answers, a positive and a -4. And also, because this is a quadratic, we know that all of the quadratics we've done up to this point give us two answers, right? Because we usually get two pairs of binomial factors, and then each one of those gives us an answer. So when we take a square root when we're solving, and we are taking the square root of x squared, we always say that this x is equal to the positive or the negative answer. So these answers up here, -4 and 4, should match these answers down here, -4 and 4. So that's just the nature of a quadratic equation. When we take the square root to solve, we need to think of the positive and negative answer. So let's look at the next one. This one is the x squared is not isolated, but I can easily do so by adding 8 and dividing by 5 and getting x squared equals 4. So now my x squared is isolated and I can take the square root. We would normally just get 2, but here I get +2 and -2 because we know that quadratics have two solutions. So -2 and +2, and that's the same answers that I got up here. Now, writing it like this is also acceptable, even if we don't have it separated. It can, plus or minus 2 is an acceptable answer. So let's look down the page. It says one reason you need to consider the positive and negative value is so that you can get the same answers as when you factored. Why do your answers make sense graphically, both in location and number of answers? So this is kind of a deep question. If I was going to, for example, graph my first one, so if I set this equal to y, and specifically when I solve for 0, if I graphed x squared minus 16, which is the form we got it into at the top, if I found the axis of symmetry, that formula is -b over 2a. Now in every single incomplete quadratic, b is 0, right? So it's always -0. There's no x term in here, it's missing. Over 2, and then this doesn't really matter, right? Because 0 divided by something is going to equal 0. So every single incomplete quadratic has an axis of symmetry right on the y-axis, right? It's always right here because x is always going to equal 0. Now when I graph that quadratic, in this case, basically it's either going to look like that facing up or the opposite facing down. So that tells me that my roots are always balanced. They're going to be a positive and negative of the same number. So in this case, right, we know that we're going to get -4 and +4. So this is, I think the picture actually means more here. Basically, it makes sense graphically both in location and number of answers. So a quadratic has 2 roots, and we'll be adding on to that concept of roots later. So I'll try to go back to this and say, okay, even though these don't have roots, they still have 2 roots. So as I said, that'll come up later. And then when b equals 0, those roots are balanced on both sides of the y-axis. So it makes sense we would get that positive answer and the negative answer of the same number. Okay, so remember back from a couple lessons ago, we talked about how graphs, when we started to graph algebra, it even made more sense. We had more power. We could understand things better and also do new things. So that graphic approach really helps us see why those answers have to be the way they are. So let's look at a couple down here. These are incomplete quadratics. It says the square root method for solving incomplete quadratics works even when the difference of perfect squares does not. So I'm going to write this, but you don't have to write it down. So for example, if I isolated this one, just watch this. That's not difference of perfect squares. So I'm kind of stuck and I can't really use factoring with what I know at this point. So incomplete quadratics, though, that method of taking the square root will always work. So I'm going to do that here instead. Sorry about this, guys. Okay, so that was frozen, so if you had a couple of moments of silence, I apologize. So taking the square root, now still, even though I can't look at my answers with factoring, I know I need a positive answer and a negative answer. So that's positive and negative square root of 7. So now we're starting to get into quadratics with irrational answers. If I wanted to write them in roster notation, it would look like this. Those are still numbers. If I type them in the calculator, if I type square root of 7, it has an irrational number, so it's a non-repeating, non-terminating decimal, but it still does have a numerical value. So from here, this one we have a little more isolating to do. We have 3x squared equals 24. So x squared equals 8. So here is our first time simplifying radicals. So this radical 8 contains perfect squares, a perfect square that goes into it. So 8 is 4 times 2. And square roots are actually distributive over multiplication. So I can rewrite the square root of 8 as the square root of 4 times the square root of 2, and that's equivalent. So going one step further, but I'm not going to forget that plus or minus, right, because I'm solving for a quadratic. This radical 4 is equal to 2, and the square root of 2, I can't break that down anymore, so it just stays inside. So these answers are -2 square roots of 2 and +2 square roots of 2. Now on the next page, we're going to take a little break and practice simplifying square roots, so you will get some practice with that, and then we'll go back to some more solving.